So we've now learned about functions and dictionaries, and it's intentional that we learn those two very close together because they come together for one specific concept in Python, the concept of frames. That concept is very important, and you hit it directly once you start programming with functions. So let me illustrate a problem or some potential problem. So here are two different programs, and on the left you have f, a function that has a variable inside called x. So there is some assignment here, x equals 5. And here you have a variable y that has value 6, and you print y inside of g. And you execute f and you execute g. Okay, so I think things are fairly simple, and they will almost certainly work the way you expected when you do this. If you execute this, you will print 5, then 6. Now what happens here? Will this work or will this not work? Will g have access to the x that's defined inside of f or not? So that's the first question that occurs once you realize you can give name to objects and that there are some blocks, some blocks of code. Which block exactly knows about what object? So that's the first question. Let's now look at the second problem. The second problem is that here we have x's everywhere. So we have a function that contains an assignment, x equals 5, and that prints x. And then we execute this code that starts with x equals 6, prints x, runs f, and then prints x again. So certainly, what will this code do? Well, this code will print 6 to start with, coming from there. It will run f, which means it will print 5, I guess on a different line. And then it exits f, and it prints x again. Now the question is, what is the value of x? Is it 6 or is it 5? So what happens here? That's precisely the question here in this lecture, and it's the question of which object is a name bound to when. This might depend on when you're asking the question. Are you asking the question inside the body of f, or are you asking the question inside the whole body of the program, of the module? So your answer, x is bound to 6 or x is bound to 5, might be dependent on which x exactly you are talking about. So before I can explain this, I need to give you some information about vocabulary. So a block is a piece of program text that is executed as a unit. So it would be a module, a function body, a class definition. We haven't seen class definition yet, but something like this. So it's easy to confuse block and indented block. The two are slightly different. For instance, a for loop will have an indented block inside, the for block if you want, but that's not exactly a block in this context. A binding we've already seen. A binding is the tying of a name to an object. So it's a name refers to a specific object. Whenever you have that you have a binding. Now a scope or a namespace, that's probably the hardest concept to understand here. It defines the visibility of a name within a block. So it's a concept that will specify whether a certain name is visible or not within a block. So occurrence of a name in the program text, so if you just look at the text and you see a certain name, it will refer to the binding of a specific, that same name, to an object in memory. But which binding? There might be more than one binding tying the same string to an object in memory. So it will actually refer to the binding established, this is complicated, in the innermost function block containing the use. Okay? So what Python will do, and this is a little preview on the next slides, is that it will look at the blocks that contain the block you are in, starting with the same block, and figure out what is the closest, if you want, binding with that same name. And once it has found that binding with that variable name, this binding is tied to an object. And that's the object that your name was referring to. Now, this means that if you are in a certain block, you have a whole set of scopes that are visible to a code block. You have the scope tied to that block and the scope tied to the block above and so on. And that's the environment. It's a set of all those scopes. And a frame is a Python object that will keep track of information about all the namespaces and the environment within a block, or the environment of a block. So let me try to give an example here. And this is definitely not an easy thing to do. So here, you'll see that there is different blocks. So there's 3 blocks. This one of f, this one of g, and this one of the whole function. So let's see what happens when I run it. So I have my program here on the left, and we'll step in it one step at a time. So I have my global frame, the frame associated to this whole block. And once I've executed the first step, I've defined f. So f refers to a certain function. The name f here refers to a certain object, this function f. Now if I step one more, I define a new binding, the binding of the name g to another function. If I step once more at step 8, I do an assignment. I assign 6 to x. And then I print x, so you'll see this program output here. Then I execute f. And when I execute f, you see that I define a new frame here, referring back to the original frame. Inside this f, and this is the crucial point, I now define a new x equals 5. Now, this x equals 6 is kept in memory in a separate frame. But here, x is equal to 5. So when I print x, when I print the object referred to by the name x, Python will look up at any binding of the name x to a certain object. Any binding? Not exactly. It will look at the closest in the sense of containment. So it's currently in block f, so it will look if block f has x defined. And it does, so it will print that. So you see here, 5 is printed. And then because no return value is given, it will return none. Now it exits, and it goes back here to executing g. So now I do g of 7, and when I do g of 7, I tie x to 7. So actually here I've defined x equals 7. And if I print x again, then I print 7. And then I'm exiting here, so I actually get rid of these two values, x equals 5, x equals 7, and I print x, I print 6. So now I'll run a very similar example to the previous one, except that I've added the function h. So the first steps will be exactly the same, except that now I know at line 8 of the definition of a function h. So inside here, there's a definition for z, so now I have a binding of the name z to the object 13. And now comes the crucial point. What happens at line 10? At line 10, I'm asking to print x comma z. Okay, so I'm expecting here x and z to be printed. Z, I know the value is 13 because z is bound to 13 within the same block. But what about x? Does x exist? What's the value? Well, the answer is yes, x exists because not because it's defined in this block, but because it's defined in one of the previous blocks. There is one of the parent blocks. There is a block that the block h depends on, where the name x is bound to an actual value. And so if you look at the closest one, and in this case there is only one, so you can't go wrong, the closest one is here. So when I do a print here, what will be printed is 6 and 13. Now I exit h, so I get rid of this frame, and I go back there, and finally I print x, so I print 6. So this was a more complicated example of scopes and frames. So now we have seen this example, and we have seen a slightly more complicated example. So it's important that we understand when exactly a new name binding will occur so that we understand what Python is doing behind the scenes. So this is the point of this slide. A new binding will occur in many different circumstances. The first and most classic case where a new binding occurs is whenever there is an assignment. Okay, so this is very simple. If you write x equals 7, you're doing a new binding of the name x to 7. Also, if you're doing a for loop, so if you're doing for I in range 5, well, there you have done a new binding of the variable name I. Okay, and this binding is valid for the whole block where for stands. Now, there's also, if you do exception handling, if you do an except clause, or if you use a with. And those are kind of unusual, or not unusual, but more advanced. So those are whenever you have identifiers. But there are other ways. So if you use formal parameters to functions, so if you have somewhere a definition of f of a, b, and you have some code here, if later on you do f of 7, 5, you're effectively binding within the block of f the name a to the object 7 and the name b to the object 5. So that all this we can already understand. There's also import statements, and this we'll see later. So if you do import my supermodule, import math, for instance, you're doing a new binding there of the name math, and you're binding math to the code of the module math. And finally, there is also class and function definitions, and this we'll see later. Now, to really understand the execution model of Python, it's important to already understand an abstract data structure. And this abstract data structure is the stack. So what can you do with a stack? Well, a stack is just a bunch of stuff piled up. So you imagine you're at the cafeteria and you have all the cafeteria trays one above the other. What can you do there? Well, you can pick the top one, or you can put one on top. And that's it. The bottom one can only be accessed after you have removed all the ones that are on top. So that's exactly the concept of a stack. And here we're using it. What are we stacking? Well, we're stacking the frames. And the frames keep track of the execution of the functions and the scopes and their relation. And each scope in Python is encoded using a dict. So it will be a dict of key value pairs where you have the key is the name and the value is the object, the Python object. Okay, so you have dictionaries, and what you're doing is piling them as stacks. So one for each successive function call, and once you exit a function, the most recent function called, then you drop that tray with the dict with all the information about the scope within that function. And you're left with a smaller stack of objects that are actually defined. So let's see this in action now for a much more complicated program that does nothing in particular, but is full of assignments and what's called nested scopes. So you can see here that there are different blocks, and the blocks are nested quite strongly. So let's run it and see what happens. So we're now running this code, and the first step is to define a new binding, a binding of the name f to a certain function, then the binding of a name g to a certain function, then the binding of a name h to a certain function. And then we start to do things. We assign here, so we do a new binding of x to 6. So we've already seen two ways here of doing a new binding. The first one is a function definition, and the second one is a variable assignment. So now we print x, so you don't see it below, but we're printing x here. You're free to run it, of course, yourself. Then we execute f. And once we execute f, we go in here and we stack on top. So it's supposed to be on top, but here it's displayed at the bottom. We stack a new frame, the frame of f. And now what Python does is that it will look exactly at the body of f, and it will try to figure out what could possibly happen here. What are all the assignments that could possibly happen? So it doesn't actually execute the code, but it looks for things like something equal blah. And it knows that whenever something equals blah, there will be a binding of something to some object. So at this stage, it determines all the new bindings that will occur, and it keeps track of it. So here it's not displayed, but in its head, Python already knows here that X will be bound to something. So then I go forward, and I now reach the actual assignment of X. So finally, we have here a new binding for X. And if I print X, you don't see it, but I print 5. And the reason is that the binding of X to 5 is the closest binding of X that the function could find when it's inside the frame F. And then I step forward. And stepping forward means I get rid of the frame that I don't need anymore, and I go back to the frame where the arrow is standing. And that's the global frame, the frame of the whole body of the function. And now I execute g of 7. And when I do g of 7, you see here a new assignment right away. So if you go back over there, when I entered the function f, I didn't have any assignment yet. I waited until reaching the line x equal 5 and executing that line. Then I had a new assignment. So here it's a bit different. I do g of 7, and as soon as I do g of 7, well, Python knows that this formal parameter x will be bound to 7. So this new parameter here occurs. But this new binding here occurs. But actually, already at this stage, Python knows that another binding will occur within the body of this function, and this binding will be a binding of I. Because indeed, I occurs inside a for clause. So I have here for I in range 5. So at some point, I will be bound within the body of G. So Python already knows this because it already looked ahead at the code of the function f. If you don't believe me, there are ways to show you that this is actually what Python is doing behind the scene. The Python tutor is not exactly completely transparent here. So I'll go over the for loop, and you see that the assignment of I changes every time, and each time I'm printing x, and here the value of x is 7. Okay, so I do this 5 times until I return none. And then finally, I execute h of yz. So again, y and z are formal parameters, so I've executed h of 4, 5. So this means implicitly that I'm binding y to 4 and z to 5, and Python knows this. Fine. And then I go on, and here I realize that I'm defining a new function, and this new function is defined within the body of h. So this is the first time we see this probably, but I have this new variable name defined and bound to some object here, deeper, the function deeper. And then finally, I execute deeper of y plus z, which is 9. So I create a new stack frame, the stack frame for a new frame, the frame for deeper, which has parent that frame here, the frame for h. And within this, I come immediately with an automatic assignment of t to 9, an automatic binding of t to 9. So the important thing to observe here is that the arrow here is pointing to the previous one, which is pointing to the previous one as well, the previous frame. So if I execute this now, I'll start printing t for I in range 5. So I'll define a new variable I, and I'll start executing this many times and printing 9 like that. And then as I finish, I go back and I successively close all my stack frames to end up here. So this is a partial explanation of what Python does behind the scene to execute your code. So maybe it's not the most important thing at this stage, but it's definitely something that's important and that you should eventually know. Otherwise, it will bite you back and you will encounter all kinds of subtleties that you didn't expect in the behavior of Python.